Hello, my name is Francisco Gabriel Martin Singes, and I will present the project entitled Synthesis Nickel MOF Sensor for NOx Detection. The nitrogen oxides, namely NOx, are pollutants which are present in the gases produced by combustion. NOx are strong respiratory irritants and can cause health damage in high concentrations. It is one of the causes of acid rains. To measure this, so-called NOx sensors are used, being the sensor's input device to provide a manipulable output of the measured physical variable. Gas sensors are produced between a chemical reaction of a certain gas and a semiconductor resistor, and the change of in the resistivity of the material with which heat reacts occur. This type of sensor requires careful characterization in the face of variation in temperature and relative humidity, since if the chemical reaction for which a resistance variation corresponds occurs at a different temperature, a measurement error will occur. Modern versions for NOx sensors need a filter to keep the sensor at high temperature where the device had good resolution, plus some delay to start measuring when turned on. For example, in the cases of measuring the NOx emission of a car, the operation of the equipment is based on a device inside the exhaust pipe where, in the first cavity, as in the figure 2, the oxygen molecules are transformed into oxygen 2-. Besides that, NO is oxidized with air to form NO2. In the second cavity, separated by a mesh, is where the NOx concentration is determined. In this, NO2 reacts to produce nitrogen and oxygen molecular, where oxygen absorbs electrons producing oxygen 2- ions, because what goes into this already reacted is proportional to what is exhaust pipe. Of the nickel MOF, a solution of nickel nitrate, melamine, urea, water, and methanol was prepared. Said solution was stirred and heated, maintaining a temperature around 50 degrees centigrade for 45 minutes. Too late place it in a hydrothermal reactor for 1 day at 160 degrees centigrade. Once this period had elapsed, the MOF formed and the vacuum filtered and dried. On the part of the results, in the figure 4 show the synthesized MOF diffraction pattern with the use of the match. It's a program. The results of X-ray diffraction were found and compared with those obtained from other compounds already reported, finding that the compound with the most coincidence with the MOF is the nickel amine nitride, which is reported from two different sources, but having a similarity with the MOF diagram for the first 5 peaks lo located from the left to right and so on, while the peaks that could not be assigned are probably due to impurities in the sample by unreacted compounds. It followed that the crystal system of the MOF is the same that of nickel amine nitride, namely cubic. Supporting this crystalline structure hypothesis, it is mentioned that it was found at high temperatures in addition to high pressure in the hydrothermal system. In the figure 5, show a photo taken of a material with an approach of 20,000 x to 20 electron volts. That's be not having a large grayscale. It can be said that there is a certain homogeneity of the compounds in the synthesized material, in addition to having spherical morphology. Analyzing the Raman spectrum in the figure 6, we can find peaks in this diagram to derive from the vibration of the NO3 bonds, what indicates good linearity between compound concentration and Raman intensity. Other peaks what attributed to bonds between nickel, others are bonds between nickel and nitrogen, oxygen and nitrogen, and carbon and nitrogen, and one peak present on 146 centimeters means one was attributed to the stiffness of the entire network, while in the figure 7 show the UVB spectrum, where is the following wavelengths. It is due to one with amino group, one with nitro group, and in 1050 nanometers, and found in the cycle in melamine. And between 550 to 650 nanometers, this signal is related to the bond that nickel has the nickel cyanine molecule. For the NOx sensor test, to carry out this experimental test in a vacuum space, a stream of NOx gases was made to flow directly into it while its amperometric response was measured. As can be seen in the figure 8, two cycles were varied outward as the nickel MOF plate was exposed. It presented a less and less response to NOx over time. This can be attributed to the plate reacting with or retain NOx, having this a very fast response to the presence of it with a minimum variation on determination. Having this small variation in current is due to the fact that the generation of nitrogen molecule is slow. It is considered a good sensor because due to the morphology of the nickel MOF, the material has the large contact area, being porous. Begin one of the reasons why the response of the material decreases. It is proposed that it is due to the porosity of the material. It retains molecules and in this way only reduces its contact area. In conclusion, it was possible to synthesize the MOF based of melamine and nickel by the hydrothermal route. A device was developed using the nickel MOF as a sensor, and NOx sensing was achieved with the nickel electrode.